Hey everybody, it's the 11th of March, 2025. This is Aiken PBL Live Coding with Gimbalabs and friends. And we're here for the second of two, what do we call these? Bad idea sessions. Things
Yep.
not to do if you're writing a validator.
Nice.
So Hinson joined us last week. If you're watching this one, there's a video right before this one in the playlist if you want to get caught up. But what are we looking at today?
Yeah, let me take over the screen sharing. Can anyone see my screen?
Looks good.
Yep. So I do a quick recap on what we have done last week. So last week we have gone through two of the back contract in the Mesh repo. In Mesh, there's a one um, package inside the core repository called Mesh contract, where here we have a few demo smart contract and how to do it with mesh kind of full stack. And for some of them, we have some back contract examples. So particular last week, we have covered the most infamous one, double satisfaction with the swap contract, and also another very popular one inside marketplace called insufficient state control. And today we've gone through 2 to 3 more to wrap the back contract sessions. So in our contrast, in the escrow, I will probably start with this escrow, this unbound value. Here we comes to the second part of the back contrast session where we probably cover a bit more less intuitive vulnerability. Because in Cardano, if you still have some memory about double satisfaction, it is very intuitive, that kind of vulnerability where you can unlock more value than uh, the lockers was expected from the contract. It is definitely a vulnerability. Another is the insufficient state control. It will also causing some of the loss of staking rewards or floating power is also another vulnerability. But here it comes to something that might feel a little bit trivial, but indeed they are quite this is possibly breaking your entire dApps if you didn't handle it adequately. So first of all, we go for this unbound value. So what is unbound value is that perhaps if you record our implementation in the swap, which we will check for whether some value is unlocked to someone. For example, here we whether we have sufficiently value paid to the initiator or the smart con or the the unlocker. But what happened is that this script might not also have sufficient control of it. Is that what happened if I'm an initiator, but I'm locking much more value than what was expected to be locking. Like for example, I have a bunch of ship tokens locking in the same validator. It sounds not kind of harmful, but it is kind of one of the I would say is a one of a also famous vulnerability on Cardano smart contract. It will lead to potential permanent lock. Because if we know about Cardano blockchain is that there are several protocol parameters. One of the very famous protocol parameter is the 16 kilobyte of transaction size. So if you allow people to unlimitedly locking value into the validator in the process, it will be possibly causing value to be permanent lock. Because you might think if it is not that easy to happen, but it's actually possible. Like for example, by having more than 100 tokens locked with the same UTXO, when you try to build a transaction with such a long length of bytes about the token value, it might be possibly greater than 16 kilobyte itself and causing the value to be permanent lock. So let's take a look into the contract. So in this escrow validator, let's maybe just take a look at the original validator start. So this is relatively a complex validator. I will not explain everything line by line, but I will try to explain the gist of the contract. So this contract is a escrow where for its use case is quite similar to the swap and other value transfer contract. But the idea is this: when you try to initiate an escrow, you could initiate it with some of the value, and then let's take a look. What are the redeemers? We have three different redeemers to call in this contract, which means user actions. So first of all, if you have a recipient, you could deposit another pair of value. Then, if both of you agree that you want to trade these two value together, you could hit with the complete trade. But if any one of you is not happy with the escrow contract itself, you could cancel it anytime. So this is the contract. So we could visualize that there are some of the state changes. Like initially, we will have the TS1 to initiate the transactions. Like TS1 initiator initiate the TX the escrow transaction, initiate the escrow. And then TS2 is going into this redeemer. Is that the recipient deposit the assets. And then TS3 is either canceling or completing the trade. Either one canceled the trade. Yeah. So what happened is that you will see this is a typical state machine patterns in Cardano development, where there are different states in the smart contracts or validator. So initially, the state is called initiation. And then when we want to have the recipient to deposit the asset, the state will be transiting into the active escrow. And then in the middle state, if anyone want to proceed with closing the state machine, you will either complete it or try to cancel the whole escrow. So the problem is that, so when I'm an initiator, I'm depositing some value into the validator. And then I'm not the one to proceed the state into the middle state, where this is the counterparty, which is the recipient to proceed into this state. So I'm the one to to provide some value into the validator at the first place. However, this is where the vulnerability potentially come from, is that someone is able to make my assets to be permanently locked by supplying a bunch of shitcoins attaching with the second stage. So let's take a look into how the current validator is implemented. We can see that yeah, this okay. Let me try to compare what is the difference between the two scripts. Unbound value. Is it? I'm thinking about, is it the original implementation also got the vulnerability that I didn't take care? So
Harsha, should we?
maybe
No, there's a little way that you can do this with the compare. There's a tool in VS Code. If you highlight both of them and say right mouse click, you can
is it?
select. Harsha showed me how to do it.
Never mind. I try to maybe also stop a bit here. See anyone if you got any question before, yeah, I proceed also.
Well, I love the high level look at it, and I think I understand the problem, which is
Mm,
if in an escrow uh transaction, a sort of a common type, um, that the one person can sort of block it by just by just depositing a bunch of like going up to that 16K limit, like depositing 100 shit tokens. And
Yep.
yeah, so I get it. And now, yeah. So I think I understand it so far.
Yep. Let me try to maybe just put 1 or 2 minutes, see if I catch what's happening. Yeah, maybe originally I think about this contract is sufficiently complicated, and I didn't particularly go through this, so I take this script as an example to explain. Yeah, let me take a look if I have exposed the test case. Okay, so maybe we directly check this one, which is the test case of the escrow validator. Yep. So we have on the right hand side, yeah, I think we have the escrow validator, and on the left hand side, this is the place that we built the test case. So just to wrap this concept a little bit, since this script is just too large, if I try to dive into the code carefully, maybe you will just overrun the session entirely. I'm afraid. So I just maybe jump into the test case explanation of how to see this vulnerability. Is that, for example, here I have a mock transactions. So for this mock transaction, we could see that for this spam current, I will be looping over and then try to merge the assets into the value. And then for the value, I will include it into the transaction inputs. So if we know about Cardano tokens, for every token, the policy ID will take up around, I remember it's at 28 bytes. Yeah. The policy ID could take up like 28 bytes. And then the token will also take up maximally 28 bytes. So if we do the math slightly, just 56 bytes times 150, it will be already causing us 8 kilobytes, which will be already half of the transactions. So when, for example, it's hackers just attach a UTXO with 300 different policies into it, it will directly is already exceeding the size limit of the transaction, and we should make sure our transaction totally kind of lock it from unlocking. So this is an example to building a transaction to having quite a lot of tokens. And then let's see if I could run the test case also. On track.
Okay.
Yeah. It is a pretty good demonstration about what will be happening. Like, since the contract itself will also evaluate might also evaluate the input of itself about the value. You can see that if you didn't control the input value, it would possibly causing to breach another protocol parameters limits, which is the execution units. You can see the memory bump into this 48 maps in memories. But if we know about the Cardano L1, is that we have a hard limits around 14 map in memories. So it's exceeding by far already. So it is a demonstration of how the vulnerability could be exposed in another dimensions. Like, we know that if the hacker want to lock 150 tokens, maybe it is causing his transaction to having 8K in size, transaction size, which is perfectly legit to do so. So if he tried to make this, for example, let's say 10K 10 kilobyte of transaction size to proceed your escrow contract. However, we try to unlock it since you know that the contract logic will go into all the values items in order to make sure the value is settled. Having such long of a unbound value will just causing your execution unit to be just failing. So I think this is a demonstration on how the unbound value works. And before I move into the next contract, see any of you got questions? Or any aha moment or yeah, any thoughts about is it something? Yeah. I see a chat saying, is there any suggested way to mitigate the unbound value? So yeah, maybe I didn't really mention much about it. We could take a look back to the scripts to see what is a possible way to mitigate it. So
Right. So
the whole
you showed us the problem, but then how do
yeah,
you get around this problem? Yeah. Yeah. I
yeah.
mean, that'd be cool.
Yeah. Maybe I just miss it. Yep. So the way to mitigate it is pretty easy. If we are having the problem of unbound value, what we have to do to mitigate it is to try to bound it. So how can we bound it? Maybe I could also, yeah, the move touching changing this code is pretty dangerous. I will not commit into the repository because a lot of people are using and not I don't want to just suddenly make their scripts to be yeah not working. But I will demonstrate how to do it in the scripts. So for example, here we have the escrow validator. We know that the unbound value vulnerability could come from here. So what we want to do is literally just guarding the transition of states from this TS1 to TS2. So we know that for the TS1, people are, this is a soft guard that we are quite confident that people will not provide unbound value because I'm the one to provide value into this validator. I don't want my money to be permanently locked. So usually we will not do any checks about this state. However, when the state changes from the TS1 to TS2, this state transition is in another user's try to move my validator state. So here's the way that we want to provide some guard here. So the issue is that when we the hacker could provide unbounded value. So what we can do usually is just have a check about is output value clean. It is it could be depends on your application logics to code this line, but let's take a look into our contrast. So our contract is the initiator could provide some value, and then the recipient could provide some value. Usually in here, we will have some assumption about the transaction itself. So for example, I do an example here is we assume each participant could only provide at max either plus 4 different kinds of assets. Then what we can do is very, very simple. Is that we try to locate the value recipient assets. No, it's this one. Let me take a look into my code. Yep. So this is the outputs because I'm looking at outputs at own address, and the own address is actually our escrow contract address. So we know that this output is the only output to the contract. So we know that output dot value, this is the value that we want to bound. And what we could do is, I want some linting, so I probably just go into this directory to space to open it up. Yeah, oh, we got it. Okay. Yep, I got the linting. So what we want to do, I remember there's a valid length. Yep, we just want to make sure that the length of the value is guarded. So for example, here, we assume we have this assumption, so we could do this kind of guard here. Just the output length. What I'm doing here is making sure the state transition is having here, the state transition is having the output value length smaller than the maximum number of access that I want. So here is ADA plus for recipient plus for initiator. Yep. So this will provide us a guarantee on the output length on the contrast, making sure nothing is locked due to unbound value. Any questions from here? Is it clear on how to mitigate it?
Hey, Hansen, just joined 2 minutes ago. That value length function, where's that defined?
Yep, this is inside the Focal library. You could
Right.
check, but essentially it's a utility to get the length of value. You could also do some list operation. It is identical.
I assume you flatten the value and then you count the length of the list.
Yep, probably that's it. Yep. So one more note before moving on to the next contract. So in a lot of the production grades Cardano contract, we will do something like this, or just be tight as this, because there are a lot of contract state transitioning where we literally just want a particular NFT for us to reference as an oracle to check its inline datum. And then a lot of the time, what we care about is the value is care about is the datum itself. And we're pretty sure that if the step is working fine, it is exactly having ADA value plus the oracle NFT value. Then we could just check whenever the oracle datum transition, we just have to check whether the length is equals to 2, which means ADA plus another token. So here I will just comment this out, making sure it's not breaking anything we have. And I'll probably push the note to the repository also. Is it all clear? Okay, then we move to another vulnerability. Let me check. What is it? got to check. Aha moment with the clean outputs. Yeah. Yeah, I think if we ever get chance to, or maybe in the futures when we're handling some really serious project and implementing Aiken, at the time you're handing over your scripts to the auditor, it is pretty certain that they will catch something unbound value in the contract, because it is very easily to be missing out, usually when we're implementing the scripts, because what we care about is usually our application logics. But this is the things that very, very Cardano specific that we will overlook quite a lot of the time. Yeah, next, let's take a look into here. Okay, this one is pretty straightforward. This is called locket value, but when someone's cached this vulnerability, it is usually not that severe in general. The locket value, the idea of locket value is very simple. Like for example, you have a applications that you're having a oracles. You want to be the central source of truth that is serving all of your validator to be referencing in. So for example, here we have the Plutus NFT. So what's Plutus NFT? The idea is super, super simple. So in early days of Cardano, when we don't have any smart contract or validators, most of the NFT projects in Cardano is using native scripts. And essentially, they are not the true NFT. True NFT as in the project owner got the right to mint exactly the same NFT to other wallets or on their own. So to make sure non-fungible token fungibles. So since Alonso era, we have the Cardano smart contract, it is possible for us to implement the Plutus script to ensure that every token with the same policy is having different token names. So this Plutus NFT contract is doing this thing. So what we are trying to do is essentially, first of all, having the Oracle NFT. This one is a one-time minting policy. We have the UTXO as the parameter input, and then we mint this Oracle NFT. We're sure that there's only single tokens possibly living on Earth or Cardano blockchain. And then we sent this one-time minting policy tokens into a Oracle validator. In this Oracle validator, we are serving one key information, which is the count. When we try to initialize the application, for example, we set the count to be 0. And whenever we want to mint the Plutus NFT, we will check against the SS name whether it equals to a name stack constructed by the count. So you could making sure that every tokens that the user is minting from your applications, it will be having the increasing count as the token name. So to make sure that the token name is not duplicated. So in this application, we know that firstly, we have to mint the Oracle NFT, and then we have to send the Oracle NFT into the Oracle. And then whenever we try to mint the Plutus NFT, we have to reference to the oracles. So it is not just referencing, it's exactly as an input, because we want to update the count. But still, yeah, we want to update the count. But the problem is that, so when we try to update the count, and at the end of everything, for example, you want to have additional check, for example, having just 100 NFT. At the time we want to just close out the minting service, there's one Oracle NFT and some mint UTXO either locker in the Oracle. So the locker value could be, could be seen as, if you don't have a mechanism for your application to stop it, it will causing some aiders and this Oracle NFT to be permanently locked in this contract and never going back to the circulations. So usually, in community, we've seen this thing as not good with the ADA economy in general, because you are locking something entirely in some contracts where you will never be able to take it out again. But alternatively, you could just take for example, some ADA back, and then you could do good for the community. So this is essentially what this vulnerability is about. And what this script's demonstrating is pretty straightforward, is that in the correct implementations, we will have this stop Oracle redeemers inside the oracles. That whenever you feel like your contract is service mission already and this is done with the service, you just stop it. And whenever you stop it, you just spend and burn the NFT, and you could take back the main UTXO and having the ADA to be released back to the ADA economy. But yeah, I add one more comment before I open the floors for the questions. But this is usually deemed as a less severe vulnerability in Cardano contract development, because there are quite a lot of projects intentionally having their reference scripts or Oracle to be permanently locked so as to give the community the confidence that the service could be running forever. Because when I having this extra endpoint implemented in the Oracle, it is possibly that the NFT minting service could be stopped by me anytime that I want, literally, in this implementation. Of course, I could add a little bit more logic guard in this process, but this is what it is. Like someone could just stop the Oracle at some point of the time. So yeah, this is I think a summary and demonstration about this lock value. Any questions from anyone about this?
Sorry, I couldn't find the mute.
Or
Yeah, thanks for this example. And Code Cow, I know you were working on something similar. So Hinson, thanks for preparing this one.
is that yeah, any aha moment or just how it feels like? How could we take the personality example and expand it to lock value on mint and unlock value on burn, pulling funds together in policy? Oh, that's pretty interesting. Yeah. I think in Cardano, there are quite a lot of different design patterns that you could do the same thing. I'm not quite sure what is Anastasia Lab TS inline design, but for here, I think it's pretty. Yeah, I could take a look. But my desktop is kind of messy. Messy. So I give a quick comment on this as I would probably do extra checking in the Plutus NFT minting side. So by the time of minting token, I might release this check, because this check is making sure my transaction is only minting one token. So if you want to extend the usability of that, is first of all release this guy to make sure that you could allow one more minting, and then you could mint another policy, lock it in another spending validator, which is serving the indexing. You could have the datum to be serving, oh, this is the minter, which is the counts of the current tokens, and then you could lock some value in the contract. And then in that particular spending contract, the extra spending contract, you have the logic of you check this asset name burning, then you could unlock it. So yeah, essentially just adding two simple scripts parallel and releasing this check to do so. Yeah. If there's no further question, I will move on to perhaps the last one. All good? So
Yeah.
this is the final one that we try to cover is what we call infinite mint. So just a disclaimer, all these contracts are, I'd say, pretty simple in nature. Not sure if it's a best way to demonstrate it, but yeah, I still try. So this is a gift card example. This example is what we take from the Aiken website. Essentially, what it do is when you try to create a gift card, you will create a tokens, and in this token, let me see. Yeah, and this token, it is a one-time minting policy with a dedicated token name. So you could mint this one-time minting policy gift card, log into the gift card validator. And in this gift card validator is not having much check, but just checking whether the gift card have been burned. If the gift card have been burned, and then you could just unlock the value in it. So essentially, it's as an application where you want to send some value to someone by just sending the tokens like minted token into a validator, and anyone who know about this gift card, you just take away the money and then treat it as a gift. So what happened about this is let's check about the infinite mint. Yeah. So I guess the original example of it is also an example of infinite mint, because when we do this, put this contract into this example, we should be just directly migrating from the Aiken repository where we didn't change anything. Oh, yeah. This is a different. Let me try to make sense of myself before I continue. On the left-hand side. Yeah. Oh, I see. Let's just name because I'm still trying to think about what is the difference. Yep. I don't think I got any idea about what's the difference, but anyway. So I just probably it might not be the best example to demonstrate it, but I'll still try to walk through what is actually happening. So for this gift card validator example, so when there is insufficient check about the minting value, you can see that, for example, this is the token that we want users to mint. However, by the same time, users could just mint the same policy, but the other token names like infinitely in the same transactions. So in this very, very simple contract, it might looks not really having any issues because we don't have much chat about it. But imagine, for example, you're trying to do a swap where in the process of liquidity providing or swapping, there are a bunch of different tokens are minted, like authorization tokens, LP tokens, and so forth. So I think in my knowledge, the first ever mint swap vulnerability being discovered by the Wing Rider is indeed this infinite mint, where when the people depositing some value as the liquidity provider, MintSwap didn't check against other value minted with the same policy, where it could just people just insert with other liquidity pools name into the tokens, then having the unlimited LP token flowing around the ecosystem, then people could just take your value to unlock other validators' value. So this is more of a complex concept to talk about in depth on when exactly it will introduce the vulnerability. But the gist is, whenever you want to check for some value minting, for example, we take a look back into the Plutus NFT, it will give maybe a better vision about how to do proper value guarding. Is that we will, most of the time, we would like to check it is the only tokens minted. So the issue of infinite mints is that you just check about whether your desired token have been minted, but you didn't check about whether this is the only token minted in your transactions. So this will causing people in the same transaction try to put in other tokens to be minted. So coming back from here, when this is infinite mint token to pair. Yep. So for example, here in the infinite mint example, in the minting token, I'm just trying to locate the one with my desired token name, and I'm ignoring the rest. So it is potentially this minting value to be having 100 in length, like same policy, but having other token names, so that when you flatten the mint value, it is having multiple items. And then when I get this information, I essentially just ignore everything else. But yeah, maybe it's essentially the same, the Aiken example. Anyway, yeah, this so this is what the vulnerability is about. So when we want to guard about this vulnerability, what we want to do is similar to the Plutus NFT. We just have to check whether the token has been the only minted value in the mint field. Then you could just guard it away. So yeah. Any questions from anyone about this? Yep. I think this is the wrap of the back contract sessions. And for all of the Aiken contract examples and the back contract example, you could be easily finding all of those in the mesh repository. So whenever you go into the mesh main repository and there's a mesh contract, and there will be quite a lot of different example scripts. Some of them are not implemented, and some of them are implemented. So the purpose of these contract is mostly for the education purposes, but some of them are actually quite popular for people to just directly use it. Like the marketplace, quite a lot of people just directly use it for having the NFT marketplace mini app to be hosted directly. So if you ever want to just dive deep into the examples and take a look into what exactly are the vulnerability, there are some slight explanation on each files. And then there's a corresponding test case about what is the vulnerability itself. So I think here we wrap the two back contract sessions. And yeah, maybe I pass the time back to James to do a slight wrap.
Amazing. Thanks. I remember when you first had this idea, and it's really cool to see it come to life. Thanks, Ensign. Yeah, let's wrap it here for today because I think that's a nice clean session and we don't really have time to go deep into anything else. We'll pick it up next week. I think Lawrence is going to join us. He's been doing some work with compilers and testing on top of Yahtzee, which I know Jingles and Hinson have been working with as well. So excited to check that out. But even if he can't make it, we can just jump into just regular Q&A. So whatever questions people have raised as they're working through things, we have this time for the rest of the spring. So looking forward to that. Any questions
Hey,
before we break?
yeah, just one last little question. Could you put the I'm looking around in the GitHub for that where those scripts were. I just want to make sure that I'm getting the right one if you wouldn't mind just drop them in. Although,
Yep,
did you do that
sure.
already?
I didn't yet. Perhaps let me just drop it right now.
Excellent.
Thanks, Jingles. Yeah, he got
Yep,
it.
let's drop it in
Nice.
the chat. Yeah.
I love the
Jingles got it
the
also.
dangerous behavior of taking us right into that code base. Tour.
I had the image of like the tightrope walker, like, you
Yeah.
know.
Oh, this is gonna be fine.
I just make sure I don't push it. Oh my goodness.
All right. Well, much appreciated once again. And yeah, looking forward to everything that's coming up. Thanks, everybody.
Beautiful. Bye,
Thanks,
y'all.
guys.
Cheers.